Hello all, welcome to my channel. I'm back with another video. Uh, in this video, we will be discussing about a feature, recently launched feature in Airflow. It's not recent, it has been there for long, but it's pretty new in terms of adoption and people using it. It's called deferrable operators. So we will see what was the challenge and why a new operator was created and see how it can help us in saving costs and everything. So let's get started. So what happens, how Airflow executes a task is it will create a worker, it will assign that task to the worker will remain there, it will uh, execute the task, and then once task is done, it will release that worker for others to consume, right? So uh, these workers have a slots, like slots in a sense, each slots is counted towards one particular task. So when a task is running, what it does, it occupies a slot. Like this slot is basically amount of parallelism that it can have. For example, let's say you are running this Airflow on a Kubernetes environment, and let's say you have capacity to run let's say 50 containers at a time. So at maximum, you can only run 15 tasks in parallel. So what this slots concept comes into picture is it can uh, help in achieving the max parallelism. It also helps us in preventing the or making the control that okay, how much of uh, total capacity, cluster capacity we can allocate to Airflow. We also have concepts of queues, pools, and priority. But in general, what happens? Each task gets a slot. Once the work is done, that slot is released for other tasks to pick it up. So what happens? Let's say many a times we have tasks which are not kind of a short-term task. It's a long-running task. Let's take an example of a task which is Spark. Let's say we are running Spark job using Airflow. So Spark job, let's say it takes 1 hour, 10 minutes. That is 70 minutes to complete its work. So we launch a Spark operator, and what it will do a Spark submit, and it will keep on polling for the results or logs that are coming from the Spark driver to see where it is successfully completed or not. So it will keep on polling for the next 70 minutes. So this container which started this task is having a slot which it cannot give to anyone else because the Airflow will, or let's say if total number of slots available was 50, so only 49 remaining slots are available for other tasks. And this task is not doing anything. It is just simply checking whether the task that I have submitted on a remote cluster has successfully uh, get executed or not. Or let's say we have another task, kind of task where we call it a sensor. What it does, it keeps on checking for an presence of a file, let's say in S3 location. So let's say we know that, okay, we start, uh, the DAG starts at 12, and we know that around 12:05 or 12:10, there is a file that gets landed up in S3. So, and as soon as it lands, we start some processing on top of it. So there is a sensor which keeps on looking. So the sensor starts at 12, and for 12 to till the file comes, this will keep on polling, keep on doing a list operation to see whether the task file has arrived or not. But that also is acquiring a slot. So this was kind of wasting resources of the cluster. So if you see, the scheduler submits the job, the executor is created, it executor submits the job, and then it keeps on waiting, it keeps on waiting for that job to completion. Or let's say if we have a sensor, so sensor keeps on polling for this time, and that there is nothing happening in between. Like it sensor polls it, again waits for 5 minutes, then again polls it, waits for 5 minutes, again polls and wait for 5 minutes. So for all those 5 minutes where the file is not there, it is acquiring a worker slot. It is acquiring a container capacity of the Kubernetes environment if we are running on Kubernetes. And if we are running on other systems, Celery or other backends, still there is a worker slot that has been occupied. So to improve upon this, earlier sensors were created with only one way. Then later on, it was added one more mode, which was a reschedule mode. So now, I mean, not now, I mean, previously itself. So sensors have two modes of running it. One was in poke and one was in reschedule mode. So in poke mode, what it used to do is it will acquire the slot all the time. It will poke, check whether the condition is met or not, and then wait, sit idle, again do the same thing. That was the poking mechanism. Uh, 2 dot, sorry, 2.1, it created this reschedule mode. In this mode, what it used to happen is that the executor scheduler will schedule the task. If the mode is rescheduled, what it will do is it will check once condition whether file is arrived or not, or whatever it was taking, the condition that it was trying to verify whether it is valid or not. So it will do that check, and then it will keep on, it will not keep on waiting. It will say if the condition is not met, the task will get rescheduled for a later point of time. So it will send a notification to the scheduler that okay, this task needs to be rescheduled. So the task state, instead of running, it changes to up for reschedule. And when a task is up for reschedule from whatever time that has been given as a reschedule time, at that time again it will be invoked. And for that time period, the worker slot is also released. Some other task will can run on that particular slot. So this was done to improve the total time that it takes for this total time sensor or a process acquires on the slot. To even further improve this, what Airflow in 2.2, it launched an operator which is called a deferrable operator. What this does, it's having, we call it in smart sensors. So what happens now is in this deferrable operator, the scheduler schedules the job or task. Executor will submit the job and will see whether it is successful or not successful. Once it sees that, okay, so let's say it is not successful, so instead of acquiring that slot, it will hand that checking, like the continuous check of that particular condition being met or not, to a triggerer service, which is an asynchronous service running back in the background. It is not running on the workers, it runs on the airflow environment, airflow system itself. So that triggerer, its job is only to check. If this triggerer will always have a trigger, it will check whether the condition is met or not. Once condition is met, then it will hand over the request back to the executor for making it as a completed job, and then scheduler will proceed ahead with the downstream task. So in this case, there is a very less resource consumption that is happening, or the slots are free for the most of the time. So uh, what they do, deferrable operators have a new state called uh, deferred. So what deferrable operators do is they suspend themselves and free up the worker slot, and they hand off the job of checking and taking action on a trigger to a triggerer. And the triggerer, what it does, sorry, when this happens, the task state changes to a new state called deferred, and during this state, the operator will be stopped and removed from its worker slot. Once the trigger finds the successful condition check, it will resume the operator at a certain method defined by the operator. So for example, let's say in the operator, you will have a task set of tasks that you are doing. Let's say function 1, function 2, function 3. So function 1 is, let's say, the Spark job submission. So you submitted that. Function 2 is the check that you are doing, okay, that whether the Spark job succeeded or not. And so function 3 is if, based on the condition that you have defined, if the task succeeds or look, the job succeeds, you do want to do some action on top of it. So what will happen? So initially, once you submit the job, you will mention the triggerer function, and trigger function will point to a new function that gets called when the trigger had successful met the condition. So when that next time that operator is called, it will start from that function, not from the beginning. That's what it means. And this triggerer is a small piece of asynchronous Python code that quickly and continuously evaluates a condition. So due to their small footprint, it's very fast, and we can run many of those small tasks in parallel and in a single parent process, which is a trigger process. That single parent process, which is a trigger service, runs for we can run many, but it runs for a whole installation in the environment. or in the installation. So the trigger service similar to the scheduler service. For example, we have a scheduler, right, in Airflow. So similarly, there is a trigger service runs an event loop, and then in that event loop, what happens is it's an asynchronous event loop, not a synchronous one, and the process runs the trigger which was received by the operator and signals task to resume when the condition is met. And the new flow that we see with the deferrable operator is the running. The task will go into running, then it will go to defer, then it will go to trigger, and then it will go to queued state so that the next thing can happen. And the scheduler, so the normal process is the workers execute the task, limited, it has limited capacity, but trigger, what it does, it will keep on checking, monitor the condition, and it is event driven. So that's the difference between the normal and this flow. To create a deferrable operator, what we need is Python 3.7 plus. Now this is Airflow is going to remove 3.9 as well, so we should be running on a higher version of Python, which supports asyncio, and then, or we can call it async IO as well, and Airflow version 2.2 plus, and the trigger service must be enabled on that particular Airflow installation, and the operator must defer itself by calling the trigger method, and the method name will this method name will be the method that it resumes. So you will have a trigger, and then you will say which method that it needs to start when the trigger says. So for example, this is a simple uh, sensor which says wait 1 hour sensor. So it will execute the task, and then it will say wait. So it will say the trigger is time delta trigger for 1 hour. So it will wait for 1 hour, and then it method name is execute complete. So once this trigger event is complete, it will start, operator will start from this method, which is you can put something in here like what you want to do when the completion is there. And for this it has to uh, implement, basically it will this is one kind of trigger, which is temporal trigger, that is there time delta. We can implement that. So trigger is the core custom code that operator will defer to, and trigger must be serializable as it is persisted in the DB. So whatever method you are writing should be serialized in the DB. Another example where, let's say, we can have a date time trigger. This was a time delta trigger. We have a date time trigger which is implemented, which is implementing the base trigger. And what it has three methods. One is init, basically define the class. Then we have serialize, because as we mentioned, this needs to be serializable and stored in DB, because it has to be stored in DB. So how do we serialize that? And then what is the run method of this particular trigger? What is the event? And then so this is how we define that deferrable operator. And there are few operators which are already available, which are created by the providers. Like now, Airflow has moved to providers approach. Earlier it was plugins, I guess. So now the providers provide the operators. We can install it, and then we can use it. So Databricks has Databricks Submit Run Deferrable operator, BigQuery Insert Job operator, GCS to BigQuery operator, Snowflake operator async. So these are different operators which are there available, which are running in async function, which can be deferred. Then we have these kinds of things that we were talking about, like sensor poke mode, as I mentioned. Task starts, occupies the worker's load, checks the condition every interval second, never releases the worker's load, and worker is blocked for the entire duration. With the same sensor with a reschedule mode, task starts, check the condition. If not met, it releases the worker slot. The scheduler marks the task as upper reschedule, and then after the configured time, the scheduler creates a new task instance. Uh, Sensors in a deferrable mode, what it does, it will task will start, checks the condition. If not met, creates a trigger in the database, releases the worker slot completely. Trigger process monitors the trigger asynchronously, and when the condition is met, it will return the trigger. It will notify the scheduler to start the task, resume the task from the place from the method that has been defined in the trigger. And benefits, this deferrable operation, because it does not take a worker slot for all the time, so we can have more resource utilization. It is resource utilization is high, resource consumption is reduced. It is resilient to failures. Like if we have long running tasks, and generally if we use sensor, or let's say if we keep a blocked worker slot, we run into a risk of having zombie task as well, and the task can fail as well. Let's say if we have running that particular task on a Kubernetes node, and the node is under pressure, that task may get evicted. So those kind of scenarios can happen. So with for a longer running jobs, and this makes it easier for us to handle those scenarios. And it makes the DAGs more event driven, like because we are not waiting for the results, continuously poking the results. I mean, we are doing it, but we are not doing in the task. So once we receive a success or a fail or condition is met, it will come back and start the process. Some caveats, say there, we cannot defer all the tasks, like not all tasks can be deferred. Um, if you think in terms of if a task has a polling mechanism, like to verify whether we can have a status check, then only we can do this process, right? That whether the task is succeeded or not. If the task doesn't have that polling mechanism or can't have a trigger mechanism, we can't do deferring on that. And also the trigger logs are not present. So if let's say something goes in wrong in your Python function, which is calling the trigger, and let's say the method name that you have passed, something goes wrong in the trigger, we don't see what happened, why it is not getting triggered. So that is something tricky. Again, we can restart the triggers and find out. But as of now, there is no logs present in the UI for us to see. So this was it. This was what I wanted to discuss. And tell, I mean, and understanding this concepts helps us in making our airflow installations and airflow executions more smoother, more more resource utilization and less resource consumption for long running tasks. So hope this was helpful. If you find it, do share it and spread the word. Thanks. Have a nice day.